Hello, I'm Sean Higgins, editor of SPAR3D.com, the SPAR3D newsletter. I'm here at the Leica Geosystems booth, and we're here today to talk about a new linear mode LiDAR sensor. Can you tell me what it is and what's special about it?
Absolutely. So this is our next leap in linear mode LiDAR technology, replacing our long-term ALS product line. So it's a brand new sensor with 2 megahertz maximum pulse rate, flying from 300 meters to 5 kilometers altitude, extremely sensitive, and we have also increased the accuracy very much with this data. So this is a brand new sensor intended for the regional mapping market, replacing current linear mode LiDAR systems.
Okay, so all these upgrades in the new system, I mean, what does that allow people to do that they couldn't do before? What makes this the next generation sensor?
So basically, one of the main problems with the previous generation systems was that we had this terrain limitation. We were forced to be within specific range gates, the number of multiple pulses in the air. But with this, you can transform from the different multiple pulses in the air. We can have total 35 pulses in the air simultaneously, and we can resolve those terrain changes within the data from multiple MPAA zones in the same data. So that's one of the big new things with this sensor. And really, when we designed this sensor, we wanted to build a sensor flexible for any LiDAR application. So basically, you should be able to fly a corridor mapping delivering more than 100 points per square meter, and you should also be able to fly high altitude wide area mapping with more than 3 kilometers SWAT delivering 2 points per square meter. So it's this flexibility for all different kinds of applications that was the focus for this sensor.
So this would be able to handle everything from, say, collecting a power line to doing a much wider area, for instance, a mountain range.
Yeah.
I mean, it can really do that range of collects.
Yeah, absolutely, and all from the same aircraft. So you collect, so you don't need to switch between helicopter and aircraft going back and forward. So this is intended to do all of those different LiDAR applications that you normally see within linear mode LiDAR.
Right. So, of course, a lot of people are interested in the relationship of linear mode LiDAR to single photon LiDAR. I mean, how do you see this relating to Leica Geosystems single photon LiDAR products?
Yeah. So basically, I mean, the single photon counting LiDAR is a fantastic product. It delivers that high point density from these huge altitudes, and no one other sensor is capable of doing that. But they are really adapted for this large area, wide area collect. The linear mode is the more accurate, you have the highest accuracy level and the most flexibility. So as I said before, from 1,000 feet to 18,000 feet, that's a quite bit of range. And so this is more intended for the regional market. The single photon is more for the countrywide, statewide market. And what's interesting is that we also bring in those together. So we use the same workflow, the real terrain workflow for both sensors, producing 6 megahertz SPL and 2 megahertz linear mode full waveform in the same workflow.
Okay, so you mentioned full waveform LiDAR. I don't know if we had talked about that so far. Can you maybe tell me a bit about that and what the benefits are of the full waveform workfall with this sensor?
Well, basically, I come from the bathymetric background, and we have worked full waveform since late 90s. So it's nothing new to us, to be honest. And of course. With the full waveform compared to our previous generation, we are, for example, able to capture much less distance between different points. So here is a pulse separation of about 30 centimeters. That was much higher. We actually will also store a number of waveform attributes from the waveform. So we are analyzing them on the fly to extract more than just the peak and the intensity. So we also do area under curve and can do a pulse width and so on, and that is stored in the last data format in the exabyte. So our strategy going forward is not normally to store the full waveform for all returns. You do that at downsample rate, but to store waveform attributes that can be used for waveform type of classifications. That's much less data, but you still have this rich information.
I understand that this uses a circular mapping pattern.
Yeah.
Can you maybe talk a little bit about the benefits of that and maybe some of the challenges of implementing that?
Well, of course the big benefit with the circular pattern is that you get both in the forward scan and the backward scan from the same position. So you kind of illuminate the objects from two different angles, and that gives a better foliage penetration, simply a higher possibility to penetrate. In the city environment, you get a better coverage on the walls of the houses and so on. So that's the big benefit. A drawback with the circular pattern has been that you have a higher density on the edges of the scan compared to the center. But that's something that we have solved with this city mapper, with this TerrainMapper. So that's a new technology that we have implemented. So now you can select a mode where you get the same density at the edges as in the center. So we call it the even point distribution mode. And also, one big benefit we have with this circular pattern is that we can actually use this LiDAR data to improve the trajectories of the flight path. So that is one of the secrets why we have increased the accuracy so much with this sensor. So it's both that we have increased the accuracy of the LiDAR itself, but it's also that we can, from the data, provide corrections to the flight trajectories and improve the total quality.
Well, thank you for taking the time to talk with me.
Thank you very much. Yeah.
Yeah.